In the summer of 1495, in the great hall of the Castello Sforzesco in Milan, a figure in polished bronze armor rose slowly from its seat before the assembled court of Duke Ludovico Sforza. It stood upright. It turned its head to survey the audience. It raised its right arm in a formal gesture. It opened its visor and worked its jaw as if to speak. The assembled nobles, ambassadors, and cardinals sat in silence, uncertain whether they were watching an entertainment or something they did not have vocabulary to describe. The figure was hollow. There was no man inside it. The mechanism moving it was made of cables, pulleys, gears, and counterweights, controlled by a system of programmable cams hidden beneath the seat. The armor was a shell. Every joint had been designed to move. Every motion had been calculated 3 years earlier by a 43-year-old military engineer in the pay of the Duke of Milan. That engineer was Leonardo da Vinci. He called the machine the Automa Cavaliere. Modern historians call it the robot knight. It was the first documented humanoid automaton in Western history. It was designed 425 years before the word robot was coined. Its designer intended it to be the first of an army. The full-scale military version was never built. Almost built. Case number 118. The Mechanical Knight from the Renaissance. Leonardo da Vinci was 43 years old in the summer of 1495. He had been living in Milan for 13 years, employed by Ludovico Sforza as a court engineer, painter, sculptor, and stage designer. His formal title on the Sforza payroll was Ingegnere Ducale. His actual responsibilities extended across fortification design, canal engineering, weapons research, portraiture, wedding pageantry, and the design of the largest bronze equestrian statue in Europe. He was arguably the most versatile engineer alive in Renaissance Italy. He was also chronically behind schedule on every project he had been assigned. The equestrian statue that the Duke had commissioned him to cast in 1482 existed in the summer of 1495 only as a 7-meter clay model in a courtyard. Leonardo had not yet cast a single piece of bronze after 13 years. The Duke had grown irritable. The court had grown skeptical. Some of Leonardo's colleagues had begun openly questioning whether he could finish anything at all. But he continued to be paid. The reason was simple. Nobody else in Milan could design what Leonardo could design. The Sforza Duke needed novelties for his court. Milan in the 1490s was one of the wealthiest and most politically exposed cities in Europe. Ludovico had claimed the ducal throne through a combination of political maneuvering, calculated marriages, and rumored assassination of his own nephew. He needed to appear powerful, cultured, and technologically superior to his rivals in Venice, Florence, Rome, and increasingly France. Court spectacles were part of that strategy. A mechanical figure that appeared to move by itself would be, in the words of a contemporary court chronicler, an object of wonder for every ambassador who witnessed it. Leonardo had been thinking about programmable mechanisms since his arrival in Milan. His notebooks from the 1480s contained sketches of self-propelled carts, mechanical lions, water-driven automata, and clockwork figures. By 1495, those sketches had matured into a specific engineering design for a life-sized humanoid figure that could stand, sit, wave its arms, turn its head, and open its jaw on programmable command. The design pages were bound into what would eventually be cataloged as Codex Atlanticus Folio 579, Codex Madrid Folios 91 through 100, and scattered sheets across 3 other manuscript collections. Some of them would not be seen again by any scholar for more than 470 years. The world in 1495 was preparing for a war very few Italians had believed possible. The previous September, Charles VIII of France had crossed the Alps at the head of an army of 25,000 professional soldiers. The invasion had been triggered by the death of the Neapolitan king and Charles's claim to the Kingdom of Naples through his Angevin ancestry. His army had marched south with almost no serious resistance, reaching Naples in February 1495 without fighting a single major pitched battle. The Italian city-states had realized, too late, that their small mercenary armies were no match for a modern French professional force equipped with heavy artillery. By the summer of 1495, the political situation had inverted. The Italian states had formed the League of Venice to expel Charles from Italy. Ludovico Sforza had signed the league and turned against his former French ally. Charles was retreating northward through hostile territory. Every prince in Italy was now calculating how to defend his territory against the next invasion, which every strategist agreed was inevitable. Milan was the wealthiest and most exposed city in the peninsula. Ludovico had a personal reason to fear French intervention. Louis of Orleans, the cousin of the French king, held a legal claim to the Milanese throne through his Visconti grandmother. If the French returned, they would come for Milan first. Ludovico needed everything his court engineers could give him: fortifications, cannons, cavalry, naval defense on the Lombard lakes, and if possible, weapons that no other European power possessed. An army of automated soldiers would qualify. Leonardo had one on paper. Here's what almost was. The robot knight was intended to be the prototype for a much larger program. The technical drawings that survive show a humanoid figure approximately the height of a tall Renaissance man, encased in the armor style of a Milanese heavy cavalryman of the late 15th century. The armor was more than decorative. It was structural. The plates were riveted onto an internal wooden and metallic skeleton. The joints at the shoulders, elbows, wrists, neck, and jaw were articulated using bearings and pivots that Leonardo adapted from clockmaking practice, then modified with his own innovations to increase range of motion. The motive power came from two independent mechanical systems. The upper body, comprising the arms, head, and jaw, was driven by a cable and pulley system anchored inside the chest cavity. The lower body, comprising the seated and standing positions, was driven by a separate gear and weight system anchored beneath the seat. The two systems were mechanically isolated from each other so that a failure in one would not disable the other. The most striking feature of the design was the control mechanism. Leonardo had adapted the programmable cam system used in medieval church clocks to sequence the movements of the knight. A rotating cylinder studded with pins would trigger cables at precise intervals, causing the knight to perform a predetermined sequence of gestures. The sequence could be reprogrammed by changing the position of the pins on the cylinder. In modern engineering terms, Leonardo had designed a mechanical computer with a physical output mechanism. It was the direct ancestor of every industrial robot that would be built 500 years later. The knight could perform approximately 8 distinct motions in various combinations. It could rise from a seated position. It could return to sitting. It could raise its left arm. It could raise its right arm. It could rotate its head. It could tilt its head. It could open its jaw. It could close its jaw. Modern reconstructions have added the possibility of coordinated hand clapping and a formal court bow. The engineering worked in principle. Leonardo's notebooks contained the required calculations for cable tension, weight distribution, and gear ratios. Every dimension has been verified by modern mechanical engineers as physically achievable using late 15th century materials and manufacturing techniques. There was no theoretical obstacle to construction. There was only the practical obstacle of finding master clockmakers, master armorers, and enough time to complete the work while the Duke's patronage lasted. Whether Leonardo actually built the knight in 1495 is a question that has been debated by scholars for decades. Contemporary court records from the Castello Sforzesco mention a mechanical figure demonstrated at a pageant for Ludovico Sforza in the summer of 1495. The description in the records is brief and unclear. Some historians have interpreted it as evidence that a working prototype was constructed. Others have argued that the demonstration was a costume performance by an actor in armor, staged to test whether the court would react as Leonardo hoped a real automaton might be received. A third group has proposed that Leonardo built a partial working prototype capable of only a few of the 8 motions, presented it as a live entertainment, and quietly abandoned the more ambitious military version when he saw how much master craftsmanship the full design would require. No physical fragment of the 15th century knight has ever been located. The design was intended as the first of a series. Leonardo's notebook pages surrounding the knight drawings contain sketches of a mechanized lion capable of walking and opening a chest containing lilies, a mechanized bird that could flap its wings and appear to sing, a self-propelled cart with programmable steering, and a mechanical drum that could beat in complex rhythms. Historians have interpreted these designs as belonging to the same broader research program on programmable mechanical systems. The military application was clearly in Leonardo's mind. Notebook pages from the same period contain designs for a chariot fitted with rotating scythe blades, a giant multi-shot crossbow, a diving apparatus for underwater sabotage, and an armored fighting vehicle that would later be cataloged as the Da Vinci tank. Leonardo was systematically inventing every category of weapon he could imagine, sometimes in the same afternoon. An automaton army would have been the logical culmination. Leonardo estimated in one notebook margin that a functioning military automaton could be produced in 12 months and reproduced in industrial quantities within 3 years, provided the Duke could supply the necessary skilled clockmakers, armorers, and metalworkers. He did not estimate a cost in ducats. He wrote instead that any state possessing such a force would be invincible on the battlefield within a generation. He was writing this while the French army was retreating through Piedmont, having demonstrated that 15th century Italian defenses were essentially useless against a modern invading force equipped with modern artillery. Ludovico Sforza read Leonardo's notes carefully. He also read Leonardo's estimates of how long other projects would take and how many of them had been delivered on schedule during the previous decade. He had commissioned the largest equestrian bronze statue in Europe from Leonardo in 1482. 13 years later, only a full-scale clay model existed in a courtyard. Leonardo had not yet cast a single piece of bronze. The Duke provided court patronage. He did not provide industrial-scale funding for automaton weapons. One meeting killed the entire program. On September 3, 1499, French forces under Louis XIII of France crossed the Alps at the head of a professional army of 30,000 men. Louis had inherited the Orleans claim to Milan through his grandmother. He had also inherited a strong military and a treasury that Charles VIII had partially rebuilt. Unlike his predecessor, Louis had specific and legal objectives in Italy. Milan fell almost without resistance. The Sforza mercenary captains defected within days of the French crossing the border. The city gates were opened on October 6th. The French entered the Castello Sforzesco the same afternoon. Ludovico Sforza had already fled north to seek help from the Holy Roman Emperor. Leonardo's studios were sealed by French administrators. His engineering notebooks were seized as potential military intelligence. The clay equestrian statue in the courtyard was used by occupying French crossbowmen for target practice and was reduced to fragments within weeks. The robot knight design pages, hidden among hundreds of other notebook sheets, were not recognized by the French administrators as anything unusual. Ludovico Sforza returned in early 1500 with a small mercenary army raised in the Alps. He was betrayed at the Battle of Novara in April 1500 by his own Swiss mercenaries, who refused to fight their countrymen serving on the French side. He was captured, chained, and shipped to a fortress at Loches in central France, where he would die in captivity 8 years later without ever seeing Milan again. Leonardo did not wait for the outcome. He had left Milan in December 1499 with the mathematician Luca Pacioli, carrying whatever notebooks he could transport by mule train through the winter passes. Everything he could not carry was left behind. He never returned to the Sforza service. Some of those notebook pages he carried made their way eventually to Venice, then Florence, then Rome. Others went to different heirs after his death. Others disappeared entirely. The robot knight drawings were among the pages Leonardo carried with him personally. Related sheets showing the mechanical lion, the walking cart, and the self-propelled figures were among the pages left behind and eventually scattered. When Leonardo died in France in 1519, his surviving notebooks were bequeathed to his pupil Francesco Melzi, who kept them intact in his family villa near Milan for the next 51 years. After Melzi's death in 1570, the notebooks were dispersed among his heirs, some of whom did not understand their value and sold them piecemeal or lost them through neglect over the following generations. The Codex Atlanticus, containing some of the knight drawings, ended up in the Biblioteca Ambrosiana in Milan in the early 17th century, where it remained largely uncatalogued for 300 years. Most of its pages were considered engineering curiosities rather than serious scientific documents. The Codex Madrid I and Codex Madrid II, containing the most detailed engineering pages, vanished into the Royal Library of Spain sometime in the late 16th century. They were misfiled during a library reorganization and considered lost. No modern scholar knew they existed until they were rediscovered by accident in the 20th century. For 470 years, the robot knight design was scattered across 3 continents in fragmentary pieces that no single scholar had assembled. The blueprints still exist, some in Milan, some in Turin, some in Madrid, some in Windsor, some possibly nowhere. In 1966, a Spanish archivist at the Biblioteca Nacional de España in Madrid was recataloguing manuscripts that had been misplaced during a 19th century reorganization of the royal collection. He opened a leather-bound volume that had been labeled by a previous cataloger as an anonymous engineering treatise of uncertain date. Inside were roughly 700 pages of drawings and technical notes in mirror script. The mirror script was Leonardo da Vinci's characteristic left-handed writing style. The engineering pages included the complete detailed drawings of the robot knight and its associated programmable control system. The rediscovery of the Codex Madrid manuscripts was announced in 1967. It was one of the most significant recoveries of Renaissance material in the 20th century. Overnight, historians of engineering had to rewrite substantial portions of the accepted story of Leonardo's technical work. Even after the rediscovery, the full significance of the robot knight was not immediately understood. The pages were cataloged as engineering curiosities. It took another 2 decades for a mechanical engineer to recognize what Leonardo had actually designed. In 1996, Mark Rosheim, a robotics engineer who had built prototypes for the NASA Jet Propulsion Laboratory, began systematically analyzing the recovered Leonardo manuscripts for evidence of humanoid mechanical designs. Rosheim had spent his career designing anthropomorphic robot arms for space applications. He recognized in Leonardo's drawings a level of biomechanical accuracy that had not been reached again until his own generation of engineers, working with computer-aided design tools and modern materials. Rosheim spent 6 years reconstructing the design. In 2002, he presented a full-scale functioning replica of Leonardo's robot knight at a symposium in Berlin. The replica performed all the motions specified in the original drawings. It sat, it stood, it waved its arms, it turned its head, it opened its jaw as if to speak. Every skeptical scholar who watched the demonstration agreed on the same conclusion. Leonardo's engineering had been correct. His mechanism could have been built in 1495. His design was fundamentally sound. Whether it actually was built in his lifetime remains uncertain. The court records are ambiguous. No 15th century fragment has survived. The most likely scenario, according to Rosheim's careful analysis, is that Leonardo built a partial prototype for the 1495 court pageant, demonstrated a limited range of motions to Ludovico Sforza, and abandoned the full military development when he realized how much master craftsmanship the industrial version would require and how limited the Duke's willingness was to fund another decade-long Leonardo project. The robot knight was never built at military scale. Nobody has publicly built an automaton army in the 500 years since. But the direct engineering lineage from Leonardo's programmable CAM system to modern industrial robotics is now well documented in the technical literature. Rosheim's 2006 book, Leonardo's Lost Robots, traces the influence of the Codex Madrid designs on 20th century mechanical engineering. NASA's Jet Propulsion Laboratory has cited the robot knight design as a reference for the mechanical joints of Mars rover manipulator arms currently operating on the Martian surface. The humanoid robots being developed by contemporary companies including Boston Dynamics, Tesla, Figure AI, and Agility Robotics use kinematic principles that Leonardo articulated in 1495. His cable and pulley actuation architecture, his CAM-based programmable control, and his articulated joint design remain the foundational architecture of humanoid robotics 5 centuries later. He designed all of it 425 years before the word robot was coined by the Czech playwright Karel Capek in a 1920 play about mechanical workers who overthrow their human masters. The reconstruction that Mark Rosheim built in 2002 is currently displayed at various technology museums under rotating loan agreements. A working duplicate is held permanently at the Museo Nazionale della Scienza e della Tecnologia Leonardo da Vinci in Milan, less than 3 kilometers from the Castello Sforzesco, where the original was demonstrated in 1495. Leonardo da Vinci died in Amboise, France, on May 2, 1519, at the age of 67. According to court records of King Francis III of France, he was buried in the Collegiate Church of Saint-Florentin at Amboise. The church was destroyed during the French Revolution in 1802. The human remains inside were scattered. His grave has never been positively identified. Some of his notebooks are still missing today. Estimates from Renaissance scholars range from 20 to 60% of his surviving work at the time of his death. What Melzi's heirs sold, what was lost in shipwrecks between Italian ports, what was destroyed by house fires, what was thrown away by uncomprehending owners in the 17th and 18th centuries, has never been fully cataloged. Additional manuscript pages continue to be identified in private European collections at a rate of roughly 1 significant discovery per decade. The blueprints still exist, some in Milan, some in Turin, some in Madrid, some in Windsor, some possibly nowhere. A mechanical humanoid figure existed on paper that could stand, sit, wave its arms, turn its head, and open its jaw on programmable command. Its designer was a 43-year-old military engineer employed by the Duke of Milan. It was intended as the prototype for an army of similar machines. The Duke of Milan was captured by the French in 1500 and died in a French prison 8 years later. Leonardo left Milan carrying whatever notebooks he could transport. Most of the automaton research was dispersed across libraries in 3 countries and misfiled for 470 years. The most detailed engineering drawings were rediscovered by accident in Madrid in 1966. A working reconstruction was built in 2002. Modern humanoid robotics traces its foundational architecture to designs that were completed in Milan in the summer of 1495 and lost to civilization for the next 4.5 centuries. The mechanical knight was never built at scale. Almost nobody knows why.